visi guru AYU, mencapai misi yang satu, permisi kita bantu.
Tahniah. Siaran langsung ini dibawakan khas kepada anda oleh Akademi Youtuber Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Hai, Assalamualaikum. Selamat petang semua. Indah berbalam si awan petang, berarak di celah pepohon ara. Pemanis kalam, selamat datang. Awal bismillah, pembuka bicara. Sekali lagi kami mengucapkan selamat datang kepada semua guru, para pelajar, ibu bapa ke Pusat Tuisyen Online Percuma yang terbesar di Malaysia, Akademi Youtuber. Anda sedang menyaksikan siaran langsung kelas tuisyen percuma secara dalam talian. Untuk petang ini kita ada subjek fizik tingkatan 4 iaitu untuk DLP. Tetapi boleh juga diikuti ada pelajar bukan DLP kerana kelas ini akan akan dikendalikan dalam dua bahasa oleh presenter kita pada petang ini iaitu Mr.Peh. Kelas ini adalah dibawakan secara langsung untuk anda oleh Akademi Youtuber Malaysia dengan kerjasama e-didik Malaysia dan Kelab Guru Malaysia. Bermula percuma, selamanya percuma. Okey, jadi sebelum kita mulakan kelas, ayo kita mulakan dengan bacaan doa, belajar dan umul kitab. Kepada yang bukan beragama Islam, anda bolehlah bertafakur mengikut kepercayaan masing-masing. Al-Fatihah. Amin, amin ya Rabbal Alamin. Jadi sebelum kita bermula, cikgu ingin mengajar anak-anak sekalian untuk kongsikan lagi link kelas kita pada petang ini kepada rakan-rakan anda di media sosial masing-masing. Mudah-mudahan lebih ramai lagi yang akan memperoleh manfaat daripada apa yang bakal dikongsikan oleh Mr.Peh seketika nanti. Okey, baiklah anak-anak, link sijil penyertaan kita akan sediakan di hujung siaran nanti dan pastikan anda isikan menggunakan email EDD ataupun email MOE, email delima dalam tempoh 30 minit selepas kelas ini tamat. Okey, jadi cikgu perkenalkan dulu barisan guru-guru yang ada di konti pada petang ini. Saya sendiri selaku moderator anda merangkap pegawai teknikal iaitu Cikgu Hasnitah, kini berkhidmat di SMK Bagan Jaya, Butterworth, Pulau Pinang. Dan presenter kita di sana, Sega orangnya, Cikgu Peh KH ataupun lebih dikenali sebagai Mr.Peh yang kini berkhidmat di Kolej Tingkatan 6 Tun Fatimah, Melaka. Okay, jadi pada petang ini Mr.Peh akan kongsikan tajuk yang seterusnya iaitu 3.2 Hukum Kepler 3.2 Kepler'S Law. So boleh tak anda bagi tahu cikgu yang menjoin kita pada petang ini, adakah anda sudah bersedia? Kalau anda sudah bersedia untuk melakukan kelas, boleh tak type pada live chat tu, sedia cikgu, I'm ready teacher, ready teacher. Kalau boleh anda juga boleh perkenalkan diri ataupun dari sekolah mana anda berada. Dan anda bolehlah respon juga kepada soalan-soalan yang akan dikemukakan oleh Mr.Peh. Typekan saja pada ruangan live chat itu dan boleh juga bertanyakan soalan sekiranya ada. Okey, baiklah cikgu tak ingin membuang masa lagi. Presenter kita pun telah bersedia. Jadi ayo kita mulakan dengan kelas pada petang ini. Silakan Mr.Peh.
Okay, thank you. Okay, so good afternoon all. I am Mr.Peh. Currently I'm teaching at College Tingkatan 6 Tun Fatimah, Melaka. So today we are going to continue the same chapter, chapter 3, gravitation, and we are going to new subtopic today. So the second subtopic today will be Kepler's law. So in this subtopic, you have to learn about 3 different concepts of the Kepler's law, and we have actually 3 learning standards for today's subtopic. Okay, before we go to our discussion, okay, so here I want to introduce to you. So we have 2 free online tuition class for you. Okay, so the first class will be at every Friday, 9:30 p.m. is the class regarding the Form 5 Physics, and now we are already at subtopic 3.2 rindangan. And the presenter for this week is Cikgu Izyan. So you may go to her channel to learn about this topic. Okay, and then another class will be like today, Form 4 Physics, and will be at 3:30 p.m. as usual. And we are going to discuss the new subtopic as I mentioned just now. And this is the Panitia Fizik SPM Akademi Youtuber. And today's together with me will be Cikgu Hasnitah. So thank you, Cikgu Hasnitah, for having me today. Okay, so before you start the class, you may get the material for today's lesson at the chat room. Okay, you may download and print out and learn together with me. So as mentioned just now, we have to learn about 3 learning standards for today's subtopic. The first learning standard will be, you have to explain 3 Kepler law, first, second, and third of the Kepler law. So let us look at the first Kepler law. The first Kepler law can be also known as law of orbits. Okay, it is stated as all planets move in elliptical orbit with the sun at one focus. Okay, so since the Kepler first law is known as law of orbits, so we need to know the knowledge about the orbits. Okay, so here will be in the shape of elliptical. So, and you can look at the GIF here. So the planet will be orbiting around the sun in one focus. So will be at the focus 1, which is labeled as sun here. So the planets in the solar system have elliptical shape, as mentioned in the statement just now. Okay, so the shape will be ellipse. Elliptical orbits have 2 foci, so or known as dual foci here. So you can look at the GIF, we have focus 1 and focus 2, but the sun will be stay at the same focus, which is focus 1 in this GIF. The sun is always stay at one of the 2 loci of the elliptical orbits. So here, there are 2 major, there are 2 axes you can see in this diagram. So there are major axis and minor axis. So as the planet orbiting the sun, so you can look at the second GIF. So the planet orbiting the sun, the planet furthest to sun at the major axis and closest to the sun at the minor axis. So here you can look at this figure. So here is actually the Earth. So when the Earth orbiting and reach at this position, so this will be the furthest position where the Earth to the sun. And then at this position, the Earth will be at the closest position to the sun. So, and here we know as the sun at minor axis. Okay, so you can see here, horizontal will be for major axis, and the vertical axis will be referring to minor axis here. So you can see the length for the major axis will be longest, which is showing that the planet is farthest to the sun. And then here, for the horizontal axis, for the vertical, which is at the minor axis, so it will be at the closest position to the sun. Okay, so here you can get actually extra information about the position which is farthest and closest to the sun. So here you can look at the picture. So the position which is farthest to the sun can be also known as aphelion. And the closest position will be also known as perihelion. So you can look at the distance label at this figure. So the Earth will be at the closest position when there is on early of January. And this position we know as perihelion, and at your syllabus, they will be known as at minor axis actually. Okay, and then the Earth will be at the farthest position to Sun, and we know as aphelion. So you can see this is a distance which is slightly greater than the position of the Earth when it is at the perihelion position. Okay, so the perihelion is actually can be known as the point in an orbit that there is the closest point to the Sun, which is at this position. The distance will be 177.1 million km. And then the aphelions will be referring to the point in an orbit that is farthest point to the Sun. So the distance will be labeled as 152.1 million km. Okay, so the distance I already labeled at the picture here, which is 147.1 million km when at the perihelion position.
Mr. Peh, there's one request from Christina. Can you please send the PDF link again? I think she didn't get it.
So the link is actually at already at initial I sent already, and you may.
I think they cannot see the previous message which is have been moved above. Sebab dia baru masuk ni rasanya.
Oh, okay. So I need to send it.
Okay. So, Christina, you may wait for a while Mr. Peh reshare to us the link for the PDF copy again, okay? So sementara itu, okay, pelajar yang lain, anda boleh juga anda boleh boleh muat turun ya. You can download the PDF material which is shared by Mr. Peh and you can print them out as well. Semuanya secara percuma, anda boleh cetak, print keluar dan gunakan bersama-sama dengan kelas ini, ataupun anda juga boleh dengar dahulu. Nanti anda boleh tonton semula video ini dan boleh lengkapkanlah modul PDF copy tersebut. Okay, so it's other way around lah. Alright.
Okay, send already the link.
Okay, thank you Mr. Peh. Okay, pelajar-pelajar yang baru masuk, Mr. Peh dah share sekali lagi link kepada PDF copy kelas kita pada petang ini. Okay, sila teruskan Mr. Peh.
Okay, so just now we explained regarding the terms of the perihelion and the aphelion. So the perihelion, as mentioned just now, will be the point which is the closest point to the Sun. Then for the aphelions will be the point in an orbit that is farthest to the Sun. So where will be in our syllabus is labeled as a major axis. Okay, and then for the perihelion will be at minor axis. Okay, so the distance already labeled in the picture. You can just look at the picture. Okay, then the distance for the aphelions will be about 152.1 million km. Okay, approaching the point by Earth, so there is the time when the Earth is at the position we know as the perihelion, which is the closest point to the Sun. So it's normally at the early of the January, and the aphelions will be occur at about early of the July. Okay, and the seasons at the perihelion, you may see during the early of the January, it will be summer at the North Pole and the winter at the South Pole. Then for the aphelions, will be vice versa. Okay, however, the season is not due to the position of the Earth at different period. It's actually due to the, okay, you can see here, the Earth is actually tilted at the angle of 23.5. Okay, so some of the students will be assume that because the distance of the Earth closest to the Sun, so will be at the summer seasons. But actually it's not. Okay, it's due to the rotation of the Earth and the revolution of the Earth around the Sun causes the 4-season phenomenon on the Earth. Okay, so here just the season occur at the point perihelion and the aphelion here. Okay, but here we focus on the farthest point to the Sun will be at the major axis, then the closest will be at the minor axis. Okay, so number 6, most orbit of the planet in the solar system have major axis and minor axis of almost the same length. Okay, so here just now we mentioned that the length for the major axis is actually longer compared to the minor axis, but normally the difference will be very small. Okay, so that you can look at this solar system. So the shape of the elliptical orbits of the planet in solar system is almost round shape. Okay, so for example, just now we mentioned that the distance of the Earth at the perihelion will be about 147.1 million km, while for the Earth at the position of aphelion, so the distance will be 152.1 million km to Sun. So the different percentage between these two positions is, you can see, is actually only 3%. Okay, so that's why we can assume that, so the planet is circular around the Sun in the shape of the, in the round shape. Okay, so the radius of the orbits is the average value of the distance between the planet and the Sun. So that means in calculation, so we are using same radius, although the position of the planet is different due to the shape is considered as almost round. Okay, however, in this Kepler's law, the shape of the planet is, the shape of the orbit is also more accurately is known as ellipse shape. Although in calculation, we can assume that this is almost in round shape. Okay, so this is activity 3.11 in your textbook. Okay, so it's to sketch the shape of an eclipse based on the concept of dual foci of the eclipse. So that means we're using two focus points to get the eclipse shape of the orbit of the planet. Okay, so here firstly you have to draw the major axis and minor axis of eclipse. So it'll be almost like the diagram diagram 1 here. So firstly you have to draw the minor and major axis. Okay, then second, stick the thumbstick at the point F1 and F2. So F1 and F2 will be here. Okay, so in this activity, you must make sure that the distance of the F1 to center here must be same, together with the distance from F2 to center. Okay, then put a loop of the thread into them. Will be like this. So the loop of the thread, so you put between them, and then tighten the thread with the tips of the pencil, which is showing at the diagram 1. Okay. Okay, so selamat petang, Alvin. Okay, then you can look at the GIF. Okay, so you have to maintain the thread tension. So that means you have to pull your pencil until the end of the thread position can reach. Okay, make sure the thread is in tension condition. Okay, so the pencil is moved in a large arc. So this pencil sketches the desired eclipse. So you can see the GIF, how we can draw the eclipse with this method. So the textbook one will be a bit different. Okay, so by using this method also can draw the eclipse more easily. Okay, so then remove the thumbstick and thread, just like this figure. Okay, so draw the small circle to the to represent the sun at F1. So with this is actually F1. Okay, draw a small circle to represent the Earth. This one on the circumference of the eclipse over here. So this is the eclipse where you draw through this method. Okay. Okay, and then the next discussion. Okay, so describe how the distance between the Earth and the Sun changes when the Earth makes a complete orbit around the Sun. Okay, so this is just now the picture I showed you at the previous slide. Okay, so you can see basically the planet will be closest at the vertical position, right? So this is at the minor axis. Okay, and then the farthest position will be at here, okay, which will be the horizontal position, and we know as the major axis here. Okay, or the added information I showed you just now. Okay, will be this. Okay, so will be at the closest position we know as perihelion, and the furthest position we know as aphelion here. Okay, so the answer can be the distance between the Earth and the Sun is farthest at the position major axis or aphelion here. Okay, and the closest to the Sun will be at the position of the vertical part we know as a minor axis or perihelion here. Okay. Okay, and then we discussed about the shape of the Earth orbit would be if the major axis and the minor axis has almost the same length. So that means it will be in the round shape. Okay, so the answer here will be round shape. Okay, so we have already finished the discussion regarding the Kepler's first law, which is regarding the law of the orbits. So which is in the ellipse shape. And you may draw the shape by using the method showing at activity 3.11 at your textbook. Okay. Okay, so here will be the second Kepler law here. Okay, so the second Kepler law we also know as the law of the area. So that means we discuss about the area. Okay, so a line that connects the planet to the Sun sweeps out equal area in equal time as the planet move in orbit. Okay, so what is the meanings here? Okay, so you can see here the GIF. So the planet is orbiting the Sun. So there is an area which is, you can see the color will be brighter. Okay, so the area will be same at each part when the duration time is the same, when the orbit is moving. Okay, so here, hot tips for this statement will be, first, the area AFB and area CFD will be the same. So you can see here will be AFB. So the area here will be same as the area CFD. So both will be have same area. And then second, as mentioned, just now is a straight up with area equal, right? Then in equal time. So that means here, time taken for A position to B position. So taken T1. Time taken in T1, okay? So the time taken for C position to D position, T2. So both will be taken the same period. For example, maybe 2 days example lah. Okay, so will be same lah at these two positions. Okay, so a planet take the same amount of time to move from A to B. So we started at T1 here. And C to D is T2. So the area AFB will be same as the area CFD. So this is a statement stated for Kepler's second law. So you must remember two things. The area is same when the time taken counted for the planet moving from one point to another point is at the same period here. Okay, then second, you can observe that the length AB is longer compared to C to D here, right, with this. So the distance AB is longer than distance CD. So what is statement showing that? So with the same time taken, but distance moving for A to B is longer. So velocity is equal to distance divide time. So when time equal, greater moving distance showing the speed will be greater. So that means the planet will be moving at higher speed at position A to B, where it is closer to Sun. Okay, compare the distance at C to D, which is will be lower. So we equal amount of time taken. Okay, so here the velocity will be lower. So the V2 here will be lower when the planet at the farthest position from the Sun here. Okay, so here, therefore, the planet is moving at higher linear speed from A to B, where I mentioned just now is due to the distance longer, but the time is with the same amount counted here. Okay, so the V1 will be, okay, you can see V1 here will be greater compared to V2. Okay, so this is 4 points you need to memorize for the Kepler's second law. It's actually very easy. So first will be area swept up will be equal when the amount of the time taken moving is the same. Okay, so from here you can see the distance moving is longer when the planet closest to the Sun. This showing that the speed, the linear speed of the planet will be increases when closest to the Sun, and vice versa here. Okay, so we have finished the discussion regarding first and second Kepler law. Okay, so first and second Kepler law will be more on concept. For the Kepler first law will be the concept regarding the law of the orbits. And then the Kepler second law will be regarding the area, time, and linear speed of the planet. Okay, so no any discussion regarding calculation for these two laws. Okay, so we can look at the first question. Okay, so the first question here is the trial question of police last year. Okay, so objective question number 10 here. Okay, so you can look at the question. The position of planet that closest to the Sun when orbiting is known as. So here you see perihelion, focal point, aphelion, and center. Okay, so here that's why I give you an extra knowledge just now, because the perihelion and the aphelion is actually not stated in the textbook here. Okay, so but just now I already explained to you. So the closest to the Sun will be at the position we know as the perihelion here. Okay, so answer here will be A lah. Okay, I already show you. Okay, the answer here. So this one you just remember what I explained just now. Okay, so the furthest will be known as the aphelions here lah. Okay, so this one will be the farthest to Sun. So the question here asking closest to the Sun, so will be perihelion. Okay, or if stated in the textbook, we accept minor as this lah. Okay, okay. Then the next question, question number 2 is the paper 2 question number 1 from Trial Kedah 2022 here. Okay, so here diagram show a planet revolve the Sun. The time taken for the planet to travel from A to B, is equal to the time taken from C to D. So this is what the information regarding the Kepler's second law, right? So the TAB will be same as the TCD here. Okay, so stack the second Kepler's second law here, just like I mentioned to you. So here two point you need to remember. So first is regarding the area. The swept area will be the same when the amount of time taken is the same. So you need to keep the definition for the Kepler's second law based on these 2 points here. Okay, so will be a line that connects a planet to sun swept out equal area. So which is this one? In equal time with this, as the planet move in the orbit. Okay, so this one will be straightforward. You just memorize the definition or statement for Kepler's second law here. Okay, then the next, complete the following sentence by ticking the correct answer. So shape of the orbits for the planets. So here got two options, circle or eclipse. So just now I mentioned to you, I repeat already. So the shape will be eclipse. Okay, it will be eclipse. Okay, because according to the Kepler first law, all planets move in elliptical orbits with the sun at one focus. Just now we draw by using the activity 3.11. Okay, so the answer here will be eclipse. Just in calculation, we assume the average radiance is almost like round shape. So we take the radiance is equal during the calculation, but is actually in eclipse shape. Okay. Okay, so what will happen to the velocity of planet when it moves apart from the sun? So it will be far from the sun. So the velocity, okay, just now I also have mentioned to you. Okay, so the speed of the planet will be increases when closer to the sun. Okay, why? Because the time second counted here is same as referring to far. C will be close. Okay, but the distance moving for the planet closest to the sun will be further. So will be longer distance. So V equal to distance divided T with the same amount of time. So for longer distance, so the speed must be longer. Okay, so here when further, okay, so the speed will be increases bertambah. Okay, is increasing. Hey, sorry, here.
Oh, the question is away, move apart from the sun. Okay, so it's correct lah.
Okay, it's correct. Sorry, just now I mentioned you is the closest. So here moving apart will be at this point. Okay, so at this point, so that means with the lower distance, same time taken, so the speed will decreases. Okay, so I missed out. I thought it's here. Here is the closest. So here should be at here farthest. Okay, further position. So the velocity decreases. Okay, so reason. So the distance traveled by the planet at shorter distance when moved apart from the sun. The distance traveled by the planet is shorter when further from the sun. Yes, it's here. Okay, it's here. You see the distance here is shorter when far away from the sun. Okay, but the distance traveled for the planet is longer. Here is longer when moved near to the sun, but at the same period. So here you must discuss the distance where traveled by the planet at farther position will be shorter, but the time taken is same. Okay, so this is the answer for second mark. Okay. Okay, then the next here. Okay, so we continue for the Kepler's third law. So the Kepler's third law involving one formula, and also we have concept also. But this part we discuss about the concept for the Kepler law. Okay, Kepler third law. So the Kepler's third law we also know as a law of period. So the square of the orbital period will be this. So T is orbital period. You can see here is square. It is directly proportional to the cube of the radians of orbits. Okay, so you can just remember by this formula. T square is directly proportional to R cube for the definition for the Kepler third law here. Okay, so here a planet which orbits with larger radians has a longer orbital period. You can see here is actually directly proportional. Okay, when the radiance is greater, so the orbital period will be longer. So here you can see in this GIF we have 4 planets here. So first will be Mercury, so which is in the gray half here. So you can see the orbital radiance here is actually small. Okay, so the radiance is smaller. Okay, so the orbital period will be shorter. While for the Mars, you can see the gradients. So the radiance will be larger. So we can see the orbital period will be longer lah. Okay. Okay, so here is the first one will be the radiance for Mercury. You can see the value 57.9 times 10 power 6 km. Then the period 0.2. So this one is the shortest. Then the mass will be furthest from the sun. Okay, so the radiance here, the radiance for the mass is actually the highest here. And then the period, orbital period will be longer, 1.9 years here. Okay, so the longer or larger of the radiance will be have a longer orbital period. Okay, so you can compare with these 4 planets I'm showing here. Okay, so planets which are further from the sun, so here will be Mars lah. Take longer time to complete 1 orbits around the sun. So we here 1 complete orbits. Okay, so for example, just now I already explained. Okay, so the Earth taken 1 year to complete 1 orbit, so we'll be showing at the blue color path here. While here will be Mars, while the Mars will be taken 1.9 years. So the BM is correct here. Okay. Okay, so conclusion here will be the larger the R, so here will be the radiance of the orbits, the longer the orbital period. Okay, so here we have the question regarding the concept for Kepler's third law here. So it's also the trial question from paper 2. Okay, so this is question 5 is regarding a conception question here. Oh, it's question 9, correct? So this one is paper 1. Paper 1. Okay, paper 1, question number 9. Okay, so the following is the conversation between a teacher and the students during the physics class. Okay, so the student asks, why does the moon take shorter time to orbit the Earth than the Earth orbit the sun? Okay. So teacher reply here. So because the radiance of the orbits for the moon is smaller, okay, compared to the radiance of the orbit of the Earth. So that's why the orbiting period for the Earth around the Sun will be longer. Okay, so conversation between teachers and the students can be conclude a law. So which law is regarding their conversation? So here the point will be the larger the radiance of the orbits, the longer the period. So R increases, T will be increases. So it will be direct proportional. So the relationship is actually discussed about the law of period. So which is the Kepler's third law lah. Oh. Okay, so the answer here will be A lah. Okay. Okay, then the next will be paper 2 question 5. This one is a conception question regarding the Kepler's third law here. Okay, so diagram show 2 satellites A and B. So here you can see there are 2 satellites A and B with the same mass revolving the Earth. So the mass is about 450 kg for both. Okay, so mass is what quantity? Okay, so this one is actually chapter 1 question. Okay, so the mass is base or scale quantity lah. Okay, this one should be very straightforward lah. No any direction, only got magnitude. So this will be considered as scalar quantity. You can also give base quantity. Okay, so base quantity is a quantity that cannot be derived. Okay, so got 7. So you can just refer to the section 1.1 in your textbook. Okay, so the second here, B. So compare the satellite mass MA and MB. So this one is very easy. So for the conception question, you may just observe the diagram and get the answer. So here you see both values is the same. Okay, so you can just give MA equal to MB in very simple method. Okay. Okay, and then compare the radiance of the orbits RA and RB. So it will be this. So you can see RA is from the center of the Earth to satellite. Then B will be from here to here. So you can see RB is longer, RA is shorter. Okay, so you can use mathematics symbol. Okay, so RA is smaller than RB. Okay, so student, if let's say you know the answer, you may type the answer in the chat room. Okay, so compare the period. Okay, so for compare the period, so you may apply the Kepler's third law here. So the T square is directly proportional to R cube. So that means when the R increases, so the T will be increases. So just now we mentioned in answer B1, so RA is smaller. So that means the period A is smaller than orbital period of B lah. Okay, so here answer period of the orbits A is smaller than B. Okay, it's very straightforward actually this question. Okay, so state the relationship between the radiance of the orbits and the period. So this one will be R. This one will be T. So again, we apply Kepler's third law here. Okay, not involve any calculation. Just with this relationship, you can answer this question. Okay, so increase lah here, right? So the longer the radiance or the larger the radiance now, so the longer the period of orbiting. Okay, just applying this formula, T square directly proportional to R cube. You may answer this all question. Okay, so state the law of physics involved. So here will be Kepler's third law lah. Okay. Okay, so explain physics concept involved in C1. So that means this one is ask you to give the definition or the statement for the Kepler's third law. So we with this formula lah. So the square of the orbital period is directly proportional to the cube of the radius of its orbit. So you can just remember this formula here, relationship here. Okay. Then what will happen to the period of revolving if the mass of the satellite A is increases? So here, satellite A currently is 450. If I say increase to 500 kg, so what will be? Is it the period revolving will be affected, which is the TA? Is it increase, decrease, or same? Okay, so from here should be unchanged, right? So because you can see from the relationship at hot tips here, so the orbital period will be only affected by the radiance of the orbits. Okay, so here the mass is not in the formula. The mass of the satellite is not in the formula, in the relationship here. So that means here will be unchanged. So reason I already stated just now. Okay, so explain your answer for question D1. So explain why it's unchanged. Because the orbital period will be affected by the orbital radiance, okay, and then not affected by the mass. So you can see the answer. Orbiting period is not influenced by mass, or you can give orbiting period will be affected or influenced by the distance between the satellite to the center of the Earth. So it is only affected by the distance between satellite and the center of the Earth here. So which is the radiance of the orbit. Okay. Okay, so Cikgu Hasnitah, we can take a break.
Okey, baiklah. Pelajar semua jangan ke mana-mana. Kita berhenti rehat seketika. Kembali lagi selepas ini. Okey, kembali lagi sebelum kita teruskan dengan topik yang seterusnya. Jadi cikgu sekali lagi ingin memberitahu anda boleh dapatkan PDF kopi slide yang disampaikan oleh Mr.Peh ini melalui link yang tertera pada skrin sekarang. So anak-anak boleh muat turun, cetak keluar dan boleh gunakan sebagai bahan ulang kaji. Okey, baik Mr.Peh, teruskan.
Okay, so we have already finished our learning center 1. So you must already know the concept for the 3 Kepler law. So the first Kepler law will be regarding the law of the orbits, which is in the eclipse shape. Then second will be the Kepler's second law regarding the law of the area. So where discuss the area and the time taken. And then the third one will be the law of the period. So where the relationship will be t squared direct proportional to r cube. Okay, so here the learning center 2 and center 3 both will be regarding the calculation for the Kepler third law. Okay, so here at best Kepler third law. So here, just now we learned already the relationship with T squared directly proportional to R cubed. So from here, will become this formula. Okay, so here how the formula can be derived. So I will show you here. Okay, so here we want to express Kepler's third law. Okay, so here basically the sixth term will be discussed in this formula for Kepler third law. So first, the capital M will be represented as the mass of the sun. Okay, it will be labeled here. And then the small letter m will be the mass of the planet over here. Okay, then the v will be the linear speed of the planet, so be here. Then r will be the orbital radiance, so be small letter r here. And then t will be the orbital period, so will be the time taken for the planet to complete one cycle. Okay, so then the f here will be the gravitational force added by the sun to the planet. Okay, so here distance traveled by the planet in one complete cycle. So just like I mentioned to you will be here. Distance for one cycle, one circle here. So again, so the D is actually one circle, right? Okay, as we assume the major axis and the minor axis the same during the calculation. Okay, so here circumference, the formula you learned already at PT3, okay, 2 pi r. Okay, and then the speed, linear speed of the planet, so will be v, time taken, a distance over time taken. So here for the distance will be 2 pi r. And then for the linear speed will be distance, which is 2 pi r. And then the time taken will be orbital period, time taken to complete one complete cycle here. So it will be t. Okay, so it will be this. Okay, and then the gravitational force added as a centripetal force. So here you may see, okay, so the planet is orbiting the Earth, so there will be centripetal force added to center of the sun here, so which is caused by the gravitational force. So again, here we're using two formula. So first will be the gravitational force adding on the planet from the sun here. Okay, so will be F equal to Gm1 m2 over r squared. So this is a formula for universal law of gravitation you learn at section 2.1. And then the centripetal force produced here, which causes the planet to moving in circular motion. Okay, so we'll be using formula F equal to mv squared over r. So both will be the same. So will be become this G, the capital M will be mass of the mass of the sun. M2 will be the mass for the planet. Okay, then the centripetal force is added by the planet. So we take the mass for the small letter m. Okay. Okay, so we cancel small letter m, and then we cancel r. So we get Gm over r equal to v squared. So v, we already get the formula v equal to 2 pi r. So we substitute v as 2 pi r over t here. Okay, so we get this. Okay, then we simplify, we'll get this formula. So here Gn over r, here will be 4 pi square r square, right, over t square. Then we moving t to another side, moving this part Gn over r to another side. So t square become 4 pi square r square times R over GM. So R times R square, we get R cube. 4 pi square will be here. Then over GM will be here. Okay, so we get the relationship will be T square equal to 4 pi square R cube over GM. And this is actually the formula you already get at section 3.1. The formula where we get the mass of the Earth. Okay, so here you can see the T square is here. M is here, where we discussed last week. So when we exchange this position, you actually get same formula here. Okay? Okay, so here, the next, you can see the GM here is fixed, where G is equal to 6.67 times 10 power negative 11. You already get the value, and we discussed last week. And then the M here referring to the mass of the sun, which is also fixed. So that means overall, 4 pi square over GM is actually the fixed value. Okay, so we can put as K, where the K constant. Okay, so you can see the R square direct proportional to R cube, we can label as, we can give the simplified formula as T square equal to R, K R cube. So the constant here will be 4 pi square over GM. Kalau okay, so here we have a question.
Ya, kita
So,
ada satu soalan sana.
section B dan C berapa markah? Okay, so B and C is actually 20 marks lah. So if I say the question drop at the last 10 marks question, can be 10. So depends on the type of question asking lah. So normally the first mark will be definition, second will be 4 marks for the concept, then 5 marks for the calculation, 10 marks for modification or decision making. So if decision making will be at question at section B.
Section B, yes.
Right? Modification will be at the
Section
section C. And then the 5 marks calculation will be at the section B. You are saying I'm not mistaken. Then section C will be the conception 5 marks. So the conception 5 marks you can refer back to the question I discussed just now. Although they want is a comparison at question number 5, but actually can be combined and become one question at section C. Okay. Okay. So I hope I answer the question. MUHG, Muhammad Mercury, Mercury Silver, HG. I'm not sure Mercury. Okay. Okay. So here so I already discussed the formula, how we derive the formula just now with this now. This part is just how we get the formula now. T square equal to 4 pi square R cube over GM now. So through these two, gravitational force adding on the planet and the centripetal force, these two formula, which is actually same the method derived at section 3.1 regarding the mass of the Earth here. Okay. Okay. So here will be the question at paper 2. It's a trial question also from Bahang last year. Okay, paper 2, question number 3. Okay, so the first question also you can see here is actually regarding Kepler's second law actually. Okay, so diagram show a planet revolve around the sun. The time taken for P to Q is equal to R to S. You see, actually it's the same question, just the alphabet used different. Okay, so the area OPQ is equal to ORS will be here. So that means the time taken, TPQ, TRS is actually equal. Right? So then the area swept out is the same here. Okay, so stack the law in both. So again, just now I explained to you already. So it's regarding area and time. So it will be Kepler's second law. Okay. And then the next question. So mark with tick for the correct statement. So here linear speed from PQ is more than RS. RS. Okay, and then here the another option here will be the linear speed of PQ is less than RS. So which one is correct? Okay, so according to just now we explained, so you can see the distance traveled when the planet furthest from the sun is shorter. So when shorter, so the speed will be lower lah. So from here you can see RS is further from the sun, so the speed for RS will be smaller. Okay. So the speed for PQ will be more. So here will be more. Okay, so answer will be this. Okay, so give the reason. Just now I also explained an example already. So we discussed about the distance. Okay, so here's the formula for V will be distance over time. So the time is the same. So the only affecting the speed will be the distance. So here you can see the distance moving for PQ is longer compared to RS. Okay. Okay, so here actually I want to discuss this question D, which is regarding the learning standard 2 application for the formula T square equal to 4 pi square R cube over GM here. Okay, so calculate the orbital period of the planet in hour if the average distance from the center of the sun to orbital is this value. So this is R. So this is M. So we want to find T. Okay, so pi fixed R cube is given. R is given already. G 6.67 times 10 power negative 11. M will be 1.99. So we just substitute all the value in the formula. Okay, so this is a value given. And then we want to get T. So with this formula, we just substitute all the value. Press your calculator. Then you may get the answer. But the question asks in hour. So make sure when you get second, then you have to divide 3,600. Okay, so here you have to divide 3,600 to get hour. You can see the question asks you in hour. Okay, so it's very straightforward. So make sure your answer in 2 decimal places and correct unit lah. Here hours lah. Okay. Okay, then the next will be prior question objective from Terengganu, question number 9. Okay, so this one will be a bit hard compared to previous one, but actually it's also quite straightforward. Okay. Okay, so what is the linear orbital speed of the moon revolve around the Earth? So the question asks you V. Then the question given you G, given you mass of the Earth. So here will be M because the center will be Earth, no more sun here. Okay, so and not planet revolve. Now is the moon revolve the Earth. So the distance given is R. You see, very straightforward. Okay, so here will be almost like this. So this is the Earth. So the moon is revolving the Earth. So the question asks you about the V, linear speed. Okay, so the question given you R and given you the M already. Okay, so here we need to apply two formula. So because we want to get V, we're using 2 pi R over T. So where we can get T, the question is not given. The question given you R only. So that means you need to get T. So the T is get from this formula. Where RQ is given, R is given, G and M is given. Okay, so G is given. So firstly, you have to get T. So you substitute all the value, which is given here, G, then this one M, this one is R. Then T, you get this value. You just press calculator. Okay, you get this one. That means square root of this value. Okay, and then the second will be substitute the T you get from first formula. Okay, and then R is already given. Then you get the answer is 7,846.61. So which will be B. Okay, just double formula compared to the just previous question. Okay. Okay, and then the next, we go to learning standard 3. Okay, so just now we already know how to get the formula for the Kepler's third law, which is T squared equal to 4 pi squared R cubed over GM. Okay, so now we need to solve the problem involving the Kepler's third law. So here we have another formula. It's actually from the relationship T squared direct proportional to R cubed. You see, but here is comparison between two planets. Okay. Okay, so here solving problem using Kepler's third law formula. Okay, so again we apply the formula we learned at learning standard 2 just now. So for Kepler's third law, relationship between T orbital period and R will be this. Okay, so now we have to compare two planets because we have, just now I showed you the formula, we have T1, T2, so definitely involve two objects. Okay, so we basically like this. So the center here will be Sun. So the unknown here, R1 will be radiance orbital 1 or planet 1. Then R2 will be orbital orbits for planet 2. Then T1 will be time second for planet 1 to complete one circle. Then T2 will be the time taken for planet 2 to complete its orbit. Okay, so here the first T1 we substitute at T. R1 we substitute in our R. And here 4 pi square and GM is fixed. Okay, so this will be the first equation. Then second we substitute T as T2. Then we substitute R as R2. So we get these two equations. Then 1 divide 2. So it will be like this. 1 will be this and this. At the above divide here. So from here you can see here, the bracket terms is the same, so you can cancel. So you get this formula just now I show you, which will be used in calculation. Or you can rearrange again. So here T1 and T2 is over. So you can rearrange, become T1 over R, T1 squared over R1 cube also actually. So you can just change the position according to mathematics rule. Okay, so here another two questions going to discuss. Okay, so here is question number 7 is a trial question. Okay, from Pahang. Okay, so here will be the paper 2 question E only, because the previous question is actually similar with the question just now I explained to you. Okay, okay, so here diagram show the moon. Moon is here, and the ISS. So the International Space Station. Okay, orbiting the Earth. Both orbiting the Earth. Okay, so the moon taken time about 27.32 days for complete the circle. Okay, and then ISS will be 92.7 minutes. So here you must be careful. The unit for the time is different. One is using days, one is using minutes. So this is what you need to highlight. Okay, how to convert the unit. Okay. Okay, so the distance moon to the center of Earth will be 3.8 times 10 power 8. Okay, so I already simplified here. So T1, this one T2, then this one is R2. Right? So we just apply. Well, we want to get R for ISS here. Okay, so we just using this formula. Then we substitute. Okay, so here the 1 will be IS. Okay, so this is in minutes. So for 27.32 day, change to minutes, you have to times 24 become hour, times 60 become minute. Okay, so square, then this one will be this value. Substitute. Then you press calculator, you get this value. So your answer must be minimum 2 decimal places. Here I put 3. And then we correct unit. Okay, and then the next, last question. Okay, also prior last year, paper 1, question number 8. Applying for this formula. Okay, so satellite P is 5 times farthest from the planet than satellite Q. So when the satellite P take 20 weeks to complete full orbits around the planet, how long will the satellite Q travel? Okay, so here you can draw lah. Sometimes you draw, you see clearly. Okay, so here, here we have 2 satellites. Here actually is satellite P. Here is satellite Q. Here actually is planet. Suppose it's planet now. Okay. Okay. So here the RQ, you can give an unknown for RQ. So here is not give any value. Okay. Then the RP will be 5 times, which is stated in this statement. Satellite P is 5 times further from a planet than satellite Q. So the satellite Q is RQ. So that means satellite P will be 5 RQ. Okay, so here is not any numbers involved. It's in the terms, in the alphabets, okay, unknown. Okay, so only the value will be T. T for P, which is 20 weeks, stated in the question already. So the question asks you, how about the orbital period for satellite Q orbiting the planet? Okay. Okay, so again, we're using the only one formula here. So we substitute TP, which is given as 20 weeks. Then RQ, we need to find. We need to, the RQ is not, is actually the terms we stated. Okay, so the distance of the satellite to the planet RQ. Then for RP will be 5 times RQ. So from here, you need to expand. 5 cube will be 125. Then 20 square, 400. Then we cancel out RQ cube. Okay, so we get this one move to here, become 400 divide 125, and then we move square to another side, become square root. So we get 1.79 week. So answer will be A. Okay. Okay, so actually the time is not enough for me to discuss more questions. Example, just now got someone asked about the section B and C, so the time is constrained here. So you can actually get more questions regarding section B, section A, section C also through the discussion where we did at the early of this year for the preparation of the students for 2022 with this link. I think the link is already given by Cikgu Hasnitah. So thank you, Cikgu Hasnitah. Okay, so that's all for my sharing. Okay, I hope that you can get what I will try to bring to you, okay, today's. Okay, thank you.
Okay, thank you very much Mr. Peh. Terima kasih atas perkongsian sebentar tadi. Sangat jelas penyampaiannya dan jangan lupa sekali lagi cikgu nak ingatkan anda boleh cetak keluar bahan yang dikongsikan oleh Mr. Peh. Boleh tonton semula video ini untuk mendapatkan jawapan lengkap bagi nota yang dikongsi oleh Mr. Peh sebentar tadi. Terima kasih kami ucapkan di atas usaha anda luangkan masa pada hujung minggu. Semoga apa yang dikongsikan oleh Mr. Peh tadi membantu anda khususnya bagi yang bakal menduduki peperiksaan peperiksaan pertengahan tahun tidak lama lagi. Kebanyakan sekolah akan mula pada 1 Ogos. Jadi cikgu harap anda semua boleh menjawab dengan baik. Okey, jadi cikgu kongsikan tadi cikgu ada kongsikan video lanjutan daripada bab ini yang anda boleh tonton lebih banyak soalan yang kami bincangkan di sana. Jadi luangkan masa untuk menonton video tersebut dan kepada yang join kelas kita pada petang ini adalah pautan sijil yang kita sediakan untuk anda. Anda jangan lupa isikan sijil ini dalam tempoh 30 minit sebelum siaran langsung kita tamat. Gunakan email EDD. Kalau tak ada email EDD, anda boleh gunakan email Delima ataupun email MOE anda. Okey, jadi itu saja daripada kami pada petang ini. Semoga apa yang dikongsikan bermanfaat buat semua. Jadi cikgu akhiri. Jangan lupa minggu depan bersama lagi dalam kelas tuition online percuma seterusnya. Kita ada pada hari Jumaat pukul 9.30 malam untuk tingkatan 5. Akan disampaikan oleh teacher Linda Nordin. Tajuk dia 3.3 EMF dan rintangan dalam. Okay, daya gerak elektrik dan rintangan dalam. Dan jangan lupa pada hari Ahad pukul 3.30 petang akan bersama dengan Cikgu Hasnitah untuk tajuk yang seterusnya 3.3 man-made satellite. 3.3 satellite buatan manusia. Okey, jadi sekian saja daripada kami. Bunga seroja di atas para, jatuh ditimpa buah perangan. Andai kata tersilap bicara, kemaafan jua kami pohonkan. Sesungguhnya segala yang baik itu daripada Allah, segala yang kurang itu daripada kelemahan kami. Terima kasih kerana memberi sokongan kepada Akademi Youtuber dan kita berjumpa lagi dalam kelas-kelas yang akan datang. Assalamualaikum, selamat petang dan bye-bye semua. Jumpa lagi.